Hello and welcome to this session. My name is Shian Nafti. I'm an authorized trainer for Google. I travel around the world delivering training to Google's clients and partners. In the next few minutes, we're going to explore resiliency and security on the Google Cloud Platform using a service mesh called Istio. Let's get right in. The first thing we're going to do is install the tools we need for the demo. The version of the service mesh we're installing is the latest supported version. That's version 1.4.5. Having installed the service mesh, we're going to proceed and enable APIs on the Google Cloud Platform that are required for this demo. Next, we're going to create a Kubernetes cluster for our application. The Kubernetes cluster will be called HTTPBin. We will create the cluster in the US, in Iowa. The machine type we're going to use is the N1 standard 4 machine type. It will be a 2-node cluster using a disk of 100 gigabytes. We're going to use the default network, enable Stackdriver, and save a bit of money by using preemptible virtual machines. With the cluster created, we're going to move on to the next step and get the credentials for the cluster. Having retrieved the cluster credentials, we're going to make sure that the current user that's logged in has admin privileges against this cluster. And to do that, we're going to create a cluster role binding, specifying the value of cluster admin as the cluster role. Next, we're going to install a service mesh that is Istio within this cluster. To do that, we're going to change into the directory we created earlier when we installed the tools. Next, we're going to use the kubectl command to create the namespace for the Istio components. Next, we're going to use Helm to install the Istio custom resource definitions. Let's check to make sure all of the custom resource definitions have been configured. We're now in a position to install Istio, the service mesh. While doing this, we're going to install some additional components. We're going to install Prometheus, Kiali, Grafana, Jaeger. We're also going to make sure that the sidecar injector webhook is enabled. With the service mesh installed, let's take a look at what we have achieved so far. To do this, we're going to navigate to the console. That's the Google Cloud console. While on the console, we're going to start off by having a look at the cluster we just created. I'm going to hide this pane. You can see here the cluster, the HTTPBin cluster, in the US Central 1B location. The cluster size is 2. We have 2 virtual machines in this cluster, and that corresponds to 8 vCPUs and 30 gigabytes of memory. We can view additional configuration on this cluster by clicking on it. Under the Details tab, you can see here a lot of information on the configuration of the cluster, as well as the node pool. We can also select the Nodes tab and view the nodes that are part of the cluster. These are the two virtual machine or compute engine instances that are part of the cluster. We can select on any of these compute engine virtual machines to view the configuration of the VM. At the top, we have a dashboard providing information on CPU, memory, and disk utilization. Workloads are displayed. These are the workloads running on the node. And at the bottom, we have some additional resource information. Let's move on to the next tab, which is the Workloads tab. And here you can see all of the workloads that were installed into the Istio system namespace. Once more, we can select any of these workloads and view additional configuration information. This is the overview that consolidates most of the important information on the workload. And there are some additional tabs that are available for exploration. Let's have a look at services and Ingress. These are the services that were configured, services and Ingress. You can see that all of these were configured in the Istio system namespace. Let's take a look at configuration. We can see here a number of configurations of the type secret and config map, also configured within the Istio system namespace. We can also view most of these configurations using the object viewer. In the object viewer, we can filter by selecting just the Istio related configuration. Having selected the Istio configurations, we can expand any of these and view any of the configuration that is available. For example, Istio policy. Let's return to the cluster tab and back to our Cloud Shell console. I'm going to expand the Cloud Shell console to make things a little bit clearer. Next, we're going to move on to the application domain. We're going to start off by creating a namespace for our application. Let's create a namespace HTTPBin. Having created the namespace, we're going to enable the namespace for automatic sidecar injection. Next, we're going to configure the gateway and virtual service. The gateway and virtual service enables access to services running within the cluster from outside of the cluster. To configure this, we're going to change to the Istio directory on the file system. And we're going to apply a YAML file. This http-gateway.yaml file contains the configuration for the gateway and virtual service. Let's apply this. Now we have the gateway and virtual services created. We're going to move on to the next step, which is step number 7. And in step number 7, we're going to change directory to the Istio directory. We're then going to apply a YAML file for the deployment and services for the HTTPBin microservice. You can see here we have a service account created along with a service and deployment. Before we begin our exploration of resiliency and security features, let's take a look at the configuration we've just performed on the Google Cloud Platform console. So on the console, I'm going to navigate to Workloads. I'm going to filter to a specific namespace. That's the HTTPBin namespace. And you can see here, that's the deployment that was configured. Let's have a look at services and Ingress. Likewise, I'm going to filter the namespace and select HTTPBin. And we can also see here the service that was created for the HTTPBin microservice. On the object viewer, I'm going to go to gateway, and you can see the HTTPBin gateway that was configured. And also under virtual service, you can see the HTTPBin virtual service as well. Let's go back to our cluster and return to our Cloud Shell console. Let's begin the process of exploring resiliency. Let's change into the Istio directory on the file system. We're now going to apply the HTTP gateway YAML file. Coincidentally, this has already been configured, and you can see here there was no change, so this remained unchanged. Let's also make sure our sample application is configured. We just verified that this was running, so again here you can see there wasn't any change because it's already configured properly. Let's invoke the application using a curl request to make sure it's running. This returned an HTTP 200 OK message, so everything appears to be running just fine. Let's invoke another URL. We also got a successful response to this request. Let's configure an additional microservice for load testing. We're going to configure the Photio microservice. The Photio microservice has been configured. While we're displaying the destination rule we're going to apply next, let's take a look at the configuration of the Photio microservice on the console. You can see here we have the Photio-deploy microservice, and that's in the HTTPBin namespace. Let's have a look at the service we just configured, and there we have the Photio service also in the HTTPBin namespace. Let's return to our Cloud Shell console. This YAML file demonstrates a sample configuration for circuit breaking. You can see that we're defining a traffic policy, configuring a connection pool, as well as configuring outlier detection. We're going to apply this destination rule, and we're going to explore the impact of this destination rule on incoming traffic. In order to generate the traffic, we're going to log into the Photio microservice and invoke a number of concurrent curl requests from the Photio microservice. Let's apply this destination rule in order to configure a circuit breaker. Having configured the circuit breaker, we're going to use the kubectl command to log into the Photio pod. Once in the Photio pod, we're going to execute the Photio command and invoke the HTTPBin service from within the Photio microservice. An HTTP code of 200 was returned, implying that the request was successfully processed. Let's move on and generate some additional load. In this next step, we're going to generate 20 requests across 2 concurrent connections. You can see that as a result of the circuit breaker that we applied, 9 requests were successfully processed and 11 requests were denied. Let's go ahead and invoke an additional set of requests. In this instance, we're going to invoke 20 requests across 3 concurrent connections. And here you can see that the system is now overloaded and all of the 20 requests were denied. Photio also allows us to view statistics. So here we're going to log into the Photio pod and invoke a URL endpoint that allows us to view statistics. And you can see here some statistics. We're going to delete the HTTP namespace and redeploy the application. Now we're recreating the namespace. Having recreated the namespace, we're going to make sure the namespace is enabled for sidecar injection. Let's move on to the next use case, which is traffic shaping. We're going to start off by changing to the directory on the file system so we can have access to all of the sample application. Having recreated the namespace previously, we're now going to configure the gateway and virtual service in this new namespace. Next, we're going to deploy 2 versions of our HTTPBin microservice. This is the YAML file for version 1 of the HTTPBin microservice. Let's apply the deployment configuration. So version 1 is created. Let's create a deployment for version 2 of the HTTPBin microservice. Okay, so we now have 2 versions. We need a service in order to be able to access the ports that are created from the 2 deployments we've just configured. Next, we're going to create a deployment for our sleep microservice. The sleep microservice will serve a similar function to the Photio microservice. We're going to log into the sleep microservice and invoke the HTTPBin microservice. Before we perform any further configuration, let's explore what we've just achieved on the Google Cloud Console. I'm going to navigate to Workloads. Under Workloads, you can see here the 2 versions of the HTTPBin application that were deployed into the HTTPBin namespace. Let's have a look at services. And here you can see the HTTPBin service also in the HTTPBin namespace. And in the object browser, we should be able to view the gateway as well as the virtual service that was configured. Let's return to our console. On our console, you can see the configuration we're going to apply next. This is a configuration for the service mesh. The top configuration enables us to create an object of the type virtual service. The virtual service defines a destination rule that directs 100% of traffic to version 1 of the HTTPBin service. So by applying this virtual service configuration, all of the incoming requests will be forwarded to version 1 of the service. We're also going to configure a destination rule, and the destination rule will enable the mesh to be aware of the two versions of the HTTPBin microservice that are currently running within the cluster. So let's go ahead and apply these two configurations. Next, we're going to log into the sleep microservice and invoke the HTTPBin application. Let's do this. The request was successful, and here we have the header information that was returned. Next, we're going to view the log file for version 1 of our microservice. In the log file, you can see here an entry that confirms the request that was made. You may recall that we previously configured a virtual service that requested 100% of the traffic to be routed to version 1 of our microservice. Let's have a look at the logs for version 2 of the microservice. This confirms that no requests were forwarded to version 2 of the microservice. Next, we're going to apply a new virtual service configuration. In this instance, we're requesting that 100% of the traffic is forwarded to version 1 of our microservice. However, we're also requesting that the traffic to version 1 is also mirrored to version 2. Let's apply this configuration. Let's log into our sleep pod and let's invoke 5 requests to the HTTPBin URL. You can see the header information that was returned 5 times. So this request was successful. Let's take a look at the log file for version 1 of our microservice. You may recall that version 1 of our microservice previously had 1 entry. Let's have a look now. You can see here that we now have 6 entries. That's the first one plus the 5 requests we've just made. Let's take a look at version 2 of our microservice. Previously, we had no entry within the log file for the version 2 pod. Let's have a look now. And in version 2, you can see we have 5 log entries, and this corresponds to the traffic to version 1 that was mirrored to the version 2 microservice. This concludes the use case for traffic shaping. Next, we're going to explore security. Let's go ahead and select option 10. We're going to start off by changing to the Istio directory. Next, we're going to configure the gateway and virtual service. You can see here information returned that the gateway is already configured and the virtual service was configured. We're now going to create 3 namespaces: full, bar, and legacy. Let's start off with the full namespace. Having created the full namespace, we're going to label the full namespace for Istio injection. Next, we're going to create the bar namespace. we're going to label this namespace for Istio's sidecar injection. And finally, we're going to create a legacy namespace, and we're not going to label this namespace. Let's start off with the full namespace. Next, the bar namespace. And finally, we're going to deploy the application into the legacy namespace. We're also going to install the sleep microservice across all of these namespaces. Let's take a look at what we have achieved so far from the Google Cloud Console. Let's navigate to Workloads. Let's filter the namespaces. So the namespaces we're interested in are the bar namespace, full, and legacy. So let's select the bar namespace. So you can see in the bar namespace, we have the HTTPBin microservice and the sleep microservice. Let's select one of these. Let's have a look at the pod that is running within this namespace. And you can see that the pod has a proxy injected within the pod. Let's go back to our workloads. Let's filter namespace to the next namespace. Next namespace is full. Let's select one of the pods. In the full namespace, we have HTTPBin as well as sleep. Let's select the sleep deployment. Let's navigate to the pod. And once more, you can see the proxy injected into the pod. Let's explore the last namespace. That's the legacy namespace. Let's have a look at HTTPBin. Let's select the pod. And in here, there is no Istio sidecar container. And that's because the legacy namespace was not labeled for automatic sidecar injection. Let's have a look at services and Ingress. You can see here that we have an HTTPBin service for the workloads in all of the three namespaces. This enables us to be able to access those workloads from within the cluster. Let's go back to our cluster tab and let's return to our demo. This is a very long command, but it is quite simple what we're trying to achieve. We're essentially logging into the sleep pod within each of the namespaces, that is full, bar, and legacy. And we're invoking an endpoint, which is the httpbin.full endpoint. In other words, we're invoking the microservice that's running within the full namespace. That is the HTTPBin microservice running within the full namespace from the sleep microservice in all of those three namespaces. Let's go ahead and invoke this. Unfortunately, this isn't well formatted. However, the results are clear. So let's go ahead and interpret this. Here we have a request from sleep in the full namespace to HTTPBin in the full namespace. The return code was 200, so that means success. Likewise, we have a request from the sleep microservice in the bar namespace to HTTPBin in the full namespace. That was also successful. And finally, we have a request from the sleep microservice in the legacy namespace to the HTTPBin microservice in the full namespace. And that request was also successful. We have a 200 code. Let's move on to the next step and enable mutual authentication within the service mesh. To do this, we're going to configure an object of the type destination rule. And in the configuration, you can see here we're specifying the host, which is the HTTPBin service within the full namespace. And we're enabling mutual authentication for that service. Let's go ahead and apply this. Next, we're going to make sure we have the right policy defined. And to do that, we're going to create an object of the kind policy. And the mode we're going to specify for mutual TLS will be the permissive mode. Let's apply this configuration. Let's repeat the request we made previously and see if anything has changed. You can see here that the request from the sleep microservice in the full namespace to the HTTPBin microservice in full was successful. The request from the sleep microservice in the bar namespace to HTTPBin in full was also successful. And the request from the sleep microservice in the legacy namespace to HTTPBin in the full namespace was also successful. So nothing changed. Having enabled mutual TLS and set the mode to permissive, we were able to successfully invoke the microservice within the full namespace for which mutual TLS has been enabled from any of the other namespaces, including the legacy namespace that doesn't have a sidecar proxy. Let's move on and apply a new configuration. In this instance, we're creating a new policy. The mode we're specifying for this new policy is the strict mode. So let's go ahead and apply this. To explore the impact of this policy, we're going to run the command we executed previously. Let's run this. Here we have confirmation that the request from the sleep microservice in the full namespace to the HTTPBin microservice in the full namespace was successful. The request from the sleep microservice in the bar namespace to the HTTPBin microservice in the full namespace was also successful. However, the request from the sleep microservice in the legacy namespace to the HTTPBin microservice in the full namespace was terminated, so that wasn't successful. And the reason this wasn't successful is because there is no sidecar container within the sleep pod in the legacy namespace, because the legacy namespace was not labeled for Istio sidecar injection. This means that with the strict mode enforced, pods need to be able to authenticate themselves against each other in order to establish a secure channel of communication between the pods. Without a sidecar container in the pod, it's impossible for the pod to be able to authenticate itself because it doesn't have access to the credentials, that is the secrets and the keys that are required for mutual TLS. This concludes our Istio Security and Resiliency demo. Thanks for watching and have a nice day.